So in this video, we're going to talk about how to apply systems of equations to solve real life problems. So what we're going to do in this video is we're going to tie together some of the concepts that we learned, and we're going to not only formulate the system of equations, we're actually going to go ahead and solve it. So remember, to write the system, we need to focus on the important information and make sure that we're defining any variables. Then we'll go ahead and set up the equations that are actually going to be in our system. Then we'll solve the equations, and then finally we'll reflect on our solutions and make sure that they're reasonable in the context of the problem. So remember, you have this chart of words and phrases that represent math symbols, and when we're looking at those sentences and we're trying to figure out the equations, make sure that you refer back to this chart. So here's what we're going to do. So we're going to read the problem carefully, and then we're going to define any variables. We'll then write equations that represent the situation that's being described and make sure that our equations are in standard form. And then we'll solve the system algebraically or using Kramer's rule in our calculator. And then we'll check to make sure that our solution is reasonable. So let's look at this example. So the fine arts department at the local community college sold tickets to their fall show. They charged $20 for adult tickets, $12 for student tickets, and $10 for child tickets. The fine arts department sold 350 tickets and made $4,650 in one night. The number of child tickets sold is the same as the number of adult tickets sold. How many of each type did the department sell? So let's think about what's unknown in this problem. We know that they sold three types of tickets that we'll call X, Y, and Z. Well, the three types of tickets are adult tickets, student tickets, and child tickets. So the reason I call these are three unknowns is because we don't know actually how many of each that they sold, right? That's what we're trying to figure out. So let's look at these phrases that we have in here. So it says that they sold 350 tickets. So that's kind of like what tells us the total, right? So if we have X plus Y plus Z all added together, that's going to equal 350. Well, then we have our total amount of money made, right? So we have $4,650. So remember, the total number of tickets sold is different than the total amount of money they made. Because when they're talking about the total amount of money they made, we need to think about how many dollars for each type of ticket. So $20 for adult, $12 for students, and $10 for child. Okay, we need to factor those values in when we're trying to figure out the total amount of money. So we can say that this is 20x plus $12 for students, so 12y, plus 10z is equal to the total, which is 4,650. So let's look at if we have another equation described in this problem. Well, it says the number of child tickets is the same as the number of adult tickets. Okay, so we know that child, which is z, is equal to x. So what we can do is we can choose which way now we want to solve this system. Because notice now that we have three equations, right? We have this first equation that's the total tickets, the second equation describing the total amount of money, and then we have this z equals x. So I think it would be a good idea to try to solve these using Kramer's rule, but remember, for Kramer's rule, we need our equations to be in standard form. These first two equations are in standard form, but this last equation is not. So I need to do a little bit of rearranging to get all my variables on the left side. So in order to do that, I'm going to go ahead and subtract x from both sides. Okay, so when I do that, this is going to become negative x plus z equals 0. Okay, so now I have my system of equations in standard form. I have x plus y plus z equals 350, right? Remember, these have coefficients of 1. And then I have 20x plus 12y plus 10z equals 4,650. And then I have negative x plus z equals 0. So you may be wondering why I skipped a space. And the reason is because we don't have a y in this equation, right? So you may be wondering what we're going to enter in our matrix. Well, if there's no y there, I can say there's basically 0y. Okay. And then let me go ahead and add in these coefficients of 1. So if we set up the coefficient matrix, it's going to look like 1, 1, 1, and then 20, 12, 10. And then the last row is going to be negative 1, 0, 1. Okay. And then our constant matrix, let me go ahead and label this. This is matrix A, and then our constant matrix B will be 350, 4,650, and 0. Okay, that's going to be our matrix B. So let's go ahead now and enter both our matrices in our calculator. So we go to second matrix and then to edit, and we need a 3 by 3 matrix for A. And so we do 1, 1, 1, and then 20, 12, 10, and then we have -1, 0, and 1. Okay, so everything looks good. So I'm going to do second quit, and then now I'm going to do second matrix, and then go to edit and choose matrix B. Matrix B is a 3 by 1 matrix. So I'm going to enter now 350, 4,650, and 0. Okay, so now I need to go back to my home screen. And remember, I'm going to do Kramer's rule. So I do second matrix, and then I choose matrix A, and then I do x to the -1, and then I do second matrix, and I'm going to choose matrix B. Okay, and then when I hit enter, it gives me the 3 values of my variables. So that means that they sold 75 adult tickets, right? Because adult tickets was X, 200 student tickets, and they sold 75 child tickets. Okay, so that's the solution to our system of equations. You could have solved this algebraically also if you wanted to. I just decided to solve using Kramer's rule because I noticed that these first two equations were already in standard form. All right, so now let's try this example. It says the total length of wires A, B, and C is 445 centimeters. Wire A is 45 centimeters longer than wire B, and wire B is half as long as wire C. How long is wire A? Well, here, once again, we have 3 unknowns, right? We don't know the length of wire A, wire B, and wire C. So if you want to, you can just leave them as these variables. You don't have to change them to X, Y, and Z unless you really want to. I'm just going to leave them as A, B, and C since that's actually what we're solving for in this problem. So here we have a sentence that tells us about the total, right? So the total length is 445. Whenever we see total, that means we're just going to add everything up, and that's going to equal 445. Then it tells us that the next sentence is A is 45 centimeters longer than B. Okay, so that means that A is, that like translates into A equals, and then we have 45 centimeters longer than B. So we would say 45 plus B. Okay, and then the next sentence it says wire B is half as long as C. Okay, so we would say that B is 1/2 of C. Okay, so now we have our system of equations. We have A plus B plus C equals 445. We have A equals 45 plus B, and then we have B equals 1/2 C. Okay, so now let's think about what we can do to go ahead and simplify this system. Well, I noticed that I have this already solved for A, right? So this tells me the value of A. So what I can do is I can plug this into my first equation using substitution. So then I would get 45 plus B, right? Because that takes the place of A, plus B plus C equals 445. Well, then what I can do is I can combine these two terms of B that are in the middle because they are like terms. So I get 45 plus 2b plus c equals 45. So I could solve this equation now, but I still have this c right here. Okay, so if there's any way I could write this c in terms of b, that would help me substitute and figure this equation out. Well, notice here I have b equals 1/2 c. Well, what if I took that equation and I multiplied both sides by 2? Let's see what that would look like. Well, that's going to give me 2b, and then here the 2 over 1 times 1/2, these will cancel, leaving me with 2b equals c. So I can now plug that in using substitution to this equation that I was working on. So I have 45 plus 2b plus 2b, which now replaces c, and that equals 445. So now I have 45 plus, and these two 2b terms are going to combine and give me 4b, and that equals 445. Well, now by subtracting 45 from both sides, I can work on solving this equation for b, right? So these will cancel, and then I have 4b equals 400, which I can solve by, dividing both sides by 4. So if I do 4b equals 400 and divide both sides by 4, that's going to give me b equals 100. Okay, so b equals 100, I finally figured out the value of one of my variables, and I can just use that to plug in and figure out everything else. So we have here b equals 1 half c. So if we say that 100 equals a half of c, right? And then I multiply both sides by 2. Let's go ahead and do that. That's going to give me 200 equals c. Okay, so the value of c is going to be 200. And then now let's go back and figure out a. Well, a was a plus b, which is 100, plus c, which is 200, equals 445. So if I combine these two terms, I have a plus 300 equals 445. So I can now solve this equation by subtracting 300 from both sides. And so that's going to give me a equals 145. Okay, so a equals 145. And since we're talking about a real life problem, remember we have units. So these are all going to be centimeters. And also these are reasonable lengths, right? It does make sense to have a wire that's 145, 100, or 200 centimeters long. Okay, so that is how you solve this system of equations. So now you can go ahead and pause the video and try doing this example on your own. So here I have the solution to this problem. So it says that Mary placed 3 separate online orders, and it gives you the items that she ordered and the cost. So 2 shirts and a pair of jeans for $40, I turned into 2x plus y equals 40, because I called shirts X, jeans Y, and Z dresses. So it says 2 jeans and a dress for $32. So that means 2y plus Z was $32. 1 shirt and 2 jeans for $35 means X plus 2y equals 35. Well, so then I rewrote this system a little bit to get them into standard form. So these kind of are almost there because the variable's on the left, but then I needed to add in those zeros because I was going to use Kramer's rule with matrices. So this 2x, and then I added in the 1y, and then there's no z there, so I added in 0z, and that equals 40. Here in the second equation, there's no x, so I added in a 0x. And then in the third equation, I added in a 0z because there's no z in this equation. So that gave me matrix A that I just set up here. And then I have matrix B, which is our constant matrix. So now I just go to second matrix, and I have entered these into our calculator using edit. You can see here I have matrix A, and then I have second matrix. Let's go back to matrix B. I have the constant matrix entered there also. Okay. So now I'm going to go to second matrix and then choose matrix A and then do inverse, and then second matrix and then choose matrix B. And it gives us the solutions. Okay. So remember the solutions here, what we're looking for are the prices of each of these items. So $15 for shirts, $10 for jeans, and $12 for dresses. So here it's asking us what's the most expensive item. So out of all of these, the shirts are the most expensive item. So you can use 3 by 3 systems of linear equations to model and solve problems related to real life situations. To solve the system, you can use algebraic methods or technology with matrices as long as you first make sure that the system is in standard form.